welcome back. We're continuing our exploration of Python in the attempt to get to a certification. Working our way through the Certified Associate in Python system or their syllabus. And this episode, and actually probably the next couple, we're going to just crank through some commands. We've gone through several logical flows and things like that, and essentially one of the first set of objectives. And now we're going to sort of swing back around and catch some commands. This episode, we're going to focus on math and random related stuff. Now, these are, we're going to have to import math. This is coming out of the math module. So we're going to have to import this. And the first one we're going to look at is seal or ceiling. And let's just go ahead and take a look at those. So for those two, let me do clear. And so if I run these, so ceiling of 2.4 is going to be a 3. Ceiling of 3.7 is going to be 4. Now you may be able to guess, now actually let me do these, because this has to do, and most of these do with non-integers, so if we're dealing with floats, but let's do this. Just to be, so the ceiling of 3 and the ceiling of 2. So notice here that basically this is ceiling is a rounding up. Even if 2.4, it's not rounding it to like 2.5, it's going to round it all the way to 3. 3.7, it's going to round it to 4. 2, it's going to round to 2. And 3, it's going to round to 3. And notice that 2, if it's 2.0, then the ceiling is going to be 2. But if we make it 2.0001, now it's going to be 3, because it's something, as long as it's at all higher than that number, it's going to jump to the next one. Now, the reverse of that is floor. And we can take that. I guess maybe not exactly the reverse, but so ceiling is going to, no matter what, go down to the go up to the next level, essentially, to the next integer, pure full integer value. If we do floor, oops, I need to make sure I actually call those and not just say I'm going to call them. So now, whoop. So if we go here, so floor, we can see 2.4, it's essentially rounding down. So it's going to go down to the nearest integer value. So 2.4 goes 2, 3.7 goes 3, 2 goes to 2, 3 goes to 3, and that's even here. If we do something above, it's still going to be down to that floor. Now let's look at trunk. Now trunk's a little different. So with trunk, we're going to take it here. And we're going to go through here, change all of these over, and we're going to see, in this case, whoop, where'd that go? There we go. Now here we're going to see with trunk, 2.4 becomes 2, 3.7 becomes 3, 2 becomes 2, and 3 becomes 3. And actually, that's at 2.001. And the reason why, what trunk does is it just basically cuts it off. It's basically like floor. I'm not sure where floor and trunk would not have the same effect. But essentially what's happening, floor is going to round down to an integer. And trunk, instead of rounding down, what it does is it just truncates to the integer portion. So anything from the decimal and then to the right just gets dropped off. So that's what a trunk is going to do for you. And now if we go to Factorial, I'm not going to do this quite the same way. Factorial is, let's do something let's do 3 and let's do 5. Just in case you don't, know what a factorial is, I'm going to go ahead and run this first, and then I'll show you how it gets to the answer. Let's do 4 while we're at it, just because that'll make it a little more obvious, I think. So now if we run factorial, so factorial of 3 is 6, 4 is 24, 5 is 120. So if you don't know, this factorial is just basically take every integer underneath it and multiply them together. So 3 is going to be 3 times 2 times 1. 3 times 2 is 6, times 1 is 6. 4 is 4 times 3 times 2 times 1. So 3 times 2 times 1 is 6 times 4. It's 24. And then 5 is just going to be 4 factorial times 5, because it's 5 times 4 times 3 times 2 times 1. And 5 times 24 happens to be 120. It's important. These are the kinds of things you're going to see pop up here and there. So it is useful to know what they mean and probably how to, let me grab that guy, how to calculate them. And there are other math functions. I'm going to flip over that just a second just to show you that there are a ton, but these seem to be the ones that are most often used. Let's see, that show up in so if you look, and I'll probably throw this link out there, but this is within the math functions, and you see there's a ton. Here's ceiling. We can do a what is this? This is a combinatorial, copy sign, factorial, which we just looked at, floor, f sums, greatest common denominator, GCD, is close, infinite. So there's a lot of is's in there, but these are the things we're going to run into, including there's trunk, and what are we doing here? Hypot, which is, I'm not sure why they use it, but here we go. This is the Euclidean norm, and it's the length of the vector from the origin to the point given by the coordinates, which is interesting enough because it's going to be coordinates. So hypot is distance to hypotenuse, distance to zeros, basically. So if we come in here and we do 2.4, 3.7, and 3, what we're going to see here is that we've got 2.4 that's the distance to the 0.0, to the origin, basically, which doesn't really make sense. It would be like an absolute value. So if we do a negative of these, then we're going to see that, look, that's an absolute value. So it's how far is that from the origin? And it's going to give you back a float. So it's basically an absolute. And then, of course, we get square root. Let's just take SQRT. And let's do square root of 100 and 625. Oh, let's just do 1024. Just because. And we're going to go a square root here. And we're going to do a square root there. And we're going to see that, here we go. So square root of 100 is 10, because 10 times 10 was 100. Square root of 1024 is 32, because 32 times 32 is 1024. Now, the other one that's really good to know is random. And I think I need two. So first, let's do... This one's going to get fun because we're going to do a random 10. Random dot random. And we're going to do that 4 times. We'll do it 5 times just because. What did I do? Oh, I'm sorry. That's right. This one doesn't take an argument. What you're going to get, and this is where things like ceiling and floor and some of that may come in handy. So now if I do this, I've got, these are the random numbers that I've got. Now if I wanted to do, let's say a random from 1 to 100, then I'm going to do this. So I'm going to generate 5 numbers from 1 to 100. And then I can do, let's just do floor of that. Well, actually, let's do, we're going to do math.ceiling, so it'll be at least, so it'll be 1 to 100. And we're going to, close that off. Pardon my typing. And so now we're going to do 5 numbers, 5 random numbers from 1 to 100. And there we go. So we just generated some random numbers, very easily done. We also have seed, choice, and sample. And let's do this. Oh, get the wrong, didn't I get that? Now watch if I do. This is not going to do. So if I do random dot seed, and I give it a number, 1, 2, 3, 4, 5. Now what we're going to see, okay, well let's do this. First, let's do this. So if I run this several times, you should be able to see that I'm getting different random numbers each time. So I get different sets. But if I seed it, now note that I'm getting the exact same response every time. So seed says force a specific seed, and it gets a little complicated into how random numbers are generated here, but basically it says that, all right, you're going to get a set of random numbers, but if I set the seed, it's always going to be the same set because it's based off of that seed, and that's good to know. Let's see if I do sample. Well, let's do choice first. Random dot choice is actually going to go from a sequence. So let's go back and pull my morning array. And so now if I do this and I do a random choice from morning array, and I'm just going to print that. So I'm going to pick 3 random choices from that. I think it'll print those. It will. So now it's going to be 10, 1, and 2. Let's do it again. Oh, that's because I have a seed in there somewhere. If I get rid of a seed, well, what did I do? Oh, I just closed that file here. So if I go, let me do this. Let's say forces the same, because I don't want to break this anymore. Random values or choices. Let's do this again. So now, without the seed, I can see that it's just going to pick a choice out of this. So I could also do colors equals, let's do red, green, blue, white, black. throw some primary colors in there. And now make this colors. So this is really useful when you need to just randomly grab some data or something like that. So now, see, white, green, black, white, red, green, green, red, black. So it's just randomly picking out of, so I can do a choice. I can randomly get a choice out of a set. And what was the last, oh, sample. And now let's do sample from here. I'm going to do it from our morning array. Whoop. And if you note, this one, I can actually, instead of doing this 3 times, I can say, like, I'm going to pull out of here, I'm going to pull 3. Let me pull 4, and let me pull 1. And this is out of morning array. So I can see what I'm getting here, 3, 4, and 1, is it's going to give me 3 choices. It gives me an array, which is 3 choices out of that sample. And note, so if I do, it's not going to give me duplicates. So if I do that same thing, and I do the morning array, which was what, 10 of them? 1, 2, 3, 4, 5, 6, 7, 10. If I do 10, it's in random order, but if you note, it's everything 1, 2, 3, 4, 5, 6. So it's not going to duplicate. So if I go beyond that, then I get an error because, and it tells me, I think, yeah, sample larger than the population, or is a negative. So you can't have a negative. And so you're randomly going to pull out of here without duplicates. You're going to randomly pull a certain number. So if you wanted to pull random colors, and you say, okay, I need just 2, I want 2 colors and I don't want the same color twice. I can come in. I'm going to do that. And I'm going to get red and black. So there is a lot of power actually built in a random sense with the random library. And so that's one of them why they want you to have an idea. Because we do see this, I've run into this more than a few times where this has been useful, particularly choice and random. Seed depends on how you want to do stuff. If you need to repeat it, particularly like, say, unit testing or something like that, you may want to verify random choices based on a certain seed. Or you may also want to have like one seed and verify that if you do a different seed, you don't get the same set of random choices. And then samples the same way. Note that seed does impact choice and sample. That being said, I think that's a good point to stop for now. We will have this in our GitHub repository as always with this latest. And next time around, we're going to continue looking at some of these commands, some of these built-in things as we are just getting more comfortable with Python. As always, go out there and have yourself a great day, a great week, and we will talk to you next time.